Hey. Hello, everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 3C. I'm Harsh Soni, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the first series of World Conference on Information Systems for Business Management through Zoom. This series is organized in extension to the ICT 4SD conference series. There's a special note for the presenters that you will be given 5 minutes for the presentation and 2 or 3 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder to conclude your presentation. And I hope you will all enjoy the knowledgeable and interactive session. And there's a special note for the presenters that you all please stay connected with us till the closing remarks. And if you have any query or any update, you can write it to me in the chat box. And before we get started, I would like to introduce you all to the chair for this session. Just a second. Professor Vijay Singh Rathore. Professor Vijay Singh Rathore is working as a professor in CSE Jaipur Engineering College and Research Center, India. He is having a 20 plus years of teaching experience. And also presently he is working as a secretary in ACN Jaipur chapter and past chairman of CSI Jaipur chapter. His core research areas include internet security, cloud computing, big data, and IoT. He has organized and participated 25 plus national and international conferences of repute. Welcome, sir.
Thank you so much. I wish all the best to all the participants.
Thank you, sir. Okay, now I'd like to start with the papers. Our first presenter is Al Imtiaz, and he's presenting on remote health monitoring system using microcontroller suitable for rural and elderly patients. Maybe he's absent in this session. Okay, so moving for our next presenter, Okok Pujie Kennedy, and he's presenting on an overview of self-organizing network as network management system in mobile telecommunication system.
Good morning, everybody. Can you hear me?
Yes, sir, we can hear you.
Okay. Should I go ahead and share?
Yes, sir, please.
Okay. Can you see my slide, please?
Yes, sir, we can.
Okay. So, good morning, everybody. Good morning, good afternoon, good night, depending on your location. My name is Engineer Dr. Kennedy Okokbuji. I am sharing on an overview of self-organizing network, SOM, as a network management system in telecommunication. These are my outline. Introduction, self-organizing, self-configuration in SOM, self-optimization, self-healing, SOM architecture in telecommunication network, my conclusion, then my references. What is SOM? It is a collection, a function of automatic configuration, optimization, diagnostication, and healing of cellular cell. It was developed by 3GPP. The goal of SOM is to reduce the capital expense, which is CAPEX, and the operational expense, which is OPEX, which would have increased due to increased number of configuration in parameters in network, rapid increased numbers of base station in network, parallel operation of 2G, 3G, and evolution package core infrastructure. the network deployment process. We have basically, because we are dealing with the OPS so we have the time and the cost, basically. In the deployment, we have the planning stage, we have the deployment stage, we have the operation, we have the optimization and maintenance stage. And then before going back, after the optimization and maintenance, if there's need for planning, it goes back. Now, the CAPAS, which is capital expense, actually covers the planning and deployment stage, while the operational expense cover the optimization and the maintenance stage. What are the benefits? A typical telecommunication network is like this diagram, whereby we have the deployment, the configuration being monitored by human, by engineers. Then we have the configuration monitored both by software and human. We have the optimization both by human and also by software, or by system. While troubleshooting also done by software and the human under planning, deployment, operational maintenance. But why we are using self-organizing network, look at how it looks like. The human is eliminated out of it. It becomes only deployment. That is when human will be there. Then every other expense, so configuration is self-configured. It does its own things itself by configuring itself, then it optimizes itself. And if there's issue in maintenance, it heals itself also. That is why the cost is always reducing. What are the benefits? Reduce installation time and cost, reduce operation, reduce OPEX due to the reduction in manual effort in connecting with monitoring, optimizing, diagnosing, and healing of network. It reduces CAPAS due to more optimization used for the element, improve user experience, improve network performance. What are the features? Now, the features consist of self-organization, self-configuration. We have a complex network. Basically, there's a setup, and once there's a setup, there's the configuration of the IT association, authentication, all those take place before initialize the radio configuration. Then that is where the self-configuration, without human intervention, all these things take place automatically. While self-optimization, it's if there's issue with one of the cells, it look for the neighboring cell, it optimize, and the neighboring cell take over the coverage. Then we have the self-healing. The self-healing, it simply means it detects and compensates for any self-configuration. Self-configuration also, this functional algorithm that are set up newly are installed automatically themselves. The aim is you just plug and play. You plug without any human error of installation or deployment. It installs itself, it configure, and it go ahead, and it's on without any human intervention. Then for sales configuration, we can see that we have the start of this, the flow chart of this is the flow chart of what I've explained earlier on before. For the self configuration, this is the flow chart. It starts up, it boosts, and the performance, it discover, it detect, it transport, and the physical configuration also. It check out the physical layer, then transport autonomy, establish connection, then every other feature establish connection is associated with IP for the new complex network, provide addresses, and thereafter establish the security tunnel, and lastly, it downloads and it's up there in the self-configuration. The other feature of self-configuration includes two cells being managed together without any human intervention. And these are the link. Number one, it reports to the others. This is how the equipment is actually link up different cells together. Then while the operational admin or manager is in there checking what is happening. Then we have the self-healing. For the self-healing, is able to detect, basically, is able to detect for a self-optimization. These are still part of a self-optimization. For a self-optimization, basically, you can see that the mobility load balance, it has mobility load balance, mobility robustness optimization, it minimizes the driver test, fast, proactive, and so on. This for the self-healing on its own, without any human intervention, is able to heal himself. That is, if there's any lack in any of the cells, if there's any lack in any of the cells, is able to diagnose it and also able to compensate for that and heal himself. An example, an illustration is this. When there's cell cartridge, it recovers automatically through the software without any human intervention on the board, on the fourth board. Example of it is as illustrated in this diagram. Let's assume there's a cell outage detection. What happened on its own with the help of some self-organizing network is able to compensate. If one of the tire have issue, the other cells, they sense it and they quickly compensate for it without any human intervention. Each of them compensate for it. Now, what are the architecture of Basically, we have three architecture according to standard. We have the central sum, we have the distributed sum, we have the hybrid sum, and we have the MS, the EM. They are all, it's just the configuration is how they relate with one another. If you see this relates with EMS parallelly, this relates differently with the mass, and this one you can see relates separately before the answer. So in conclusion, the introduction of sum into long-term evolution cell network has reduced drastically the capital cost and the operational cost and improved the performance of the network. Standard by 3GPP is now becoming possible for every equipment that's installed to conform with the standard sum for each integration differ OEM device on the network. Now, in addition to the conclusion, it simply means that any vendor that want to get any equipment into the system must follow the SOM standard so that there will be little human intervention. It's just like plug and play. And these are what is happening in the telecom world. It minimizes human error and also eliminates human intervention to the barest minimum. These are my references. Thank you for listening. Thank you very much.
Yeah, am I audible?
Yeah, I'm done.
It was a very nice presentation and very nice details you have given. So thank you so much to you for this presentation. You told that it is reducing the cost. So can you tell us again how it is reducing the cost?
Come again, please.
Yeah, how it is reducing the cost? You told that the cost has been reduced by the introduction of this particular thing. So how the cost is being reduced?
The cost is being reduced. The cost is being reduced. First of all, can you see my slide? Can you see this slide, please?
Okay.
I'm coming. I want to show you how the cost is being reduced. Okay. Can you see this slide now? This is how it's being deployed: planning, deployment, and optimization, okay, and maintenance. Now, in the planning, because the equipment, all equipment now have the self-organizing network integrated in it. Okay. So if you come, you don't configure the equipment any longer. You plug, and there's a software already inside. It installs automatically itself irrespective of the equipment or the manufacturer on the network, on the telecommunication network, without any much human intervention. So you don't need much expertise because the standard is adhered by all vendors. Is it clear?
Okay, very nice.
Okay.
I got it. Thank you so much.
Welcome, sir.
Thank you so much.
Welcome, sir.
Okay, thank you so much, sir, for the great presentation. Now, I would like to recall our first presenter. Just a second. Al Imtiaz, and he's presenting on remote health monitoring system using microcontroller, suitable for rural and elderly patients. The presenter, you may please start your presentation.
Thank you, sir. Here I'm sharing my slides. Okay. Is it visible to you? My slides?
Yes, sir, it is visible.
Okay, thank you. Thank you, sir, and thank you all for for giving me this opportunity to present our work. The title of our work is Remote Health Monitoring
Sir,
System.
can you please make it full screen?
Sir, sorry.
Please make the slide to in full screen.
May I
In full screen,
continue?
sir. Press F5 so it will be on full screen.
Full screen view.
Yes, sir. Yes.
Yes. Okay. Is it
No,
okay?
now it's okay. Now it's okay.
Okay, thank you. Okay. Myself, I am Al Imtiaz, Department of CSE, University of Information Technology and Sciences. Here are the contents. The contents includes motivation, components, and peripheral device, and how we have designed and the results of our prototypes. And here is the motivations. As we have mentioned that we are developing a device which can monitor our health system and suitable for rural and elder patients. And we can see, we all know that for COVID-19 era, the physical distance is one of the important concern, and other other concern is for elder who lived in a sometimes in remote place or in a room, and we don't have enough persons or enough facilities to take care all the time. So most of the time we have to appoint another person to continuously take care of them. Here we are trying to develop a system which can monitor the health conditions remotely. And as we know, this is not a unique project, and there are lots of similar projects which have done before. But in this project, we have focused on cost minimizations. The next, here are our components and other devices we have used to develop our project. And we will see later the description of the project. And here's the model and block diagram. You can see that here are three types of sensor: heartbeat sensor, oxygen saturation sensor, and temperature sensor. And all the sensor will work on the patient's fingertip. And we are using a microcontroller, and microcontroller will analyze the information provided from the sensor, and if it requires that to inform a doctor or caretaker, it will send a SMS to DSS module. Okay, the next is the circuit diagram and interfacing, how we have connect our equipments with the microcontroller. And next, this is the important part, our programming, that means our algorithm, how we have designed our systems. And here we can see we can start after starting our device, we have to initialize the system. After that, we will active or check all our sensors are working properly, and if everything is okay, then if a patient provide his or her finger on the system, and that system will detect the heartbeat and oxygen saturation and temperature, and based on the threshold value, the threshold value is here we have used the average threshold value, but there is an option to customize based on the doctor suggestion. Patient to patient it may vary, so we can customize the threshold value for each patient, and based on the threshold value, if it goes the bar below the minimum bar or more than the upper bar, then it will send a SMS to the doctor. Otherwise, if a patient check the regularly check the heartbeat or temperature and oxygen saturation, the caretaker or a relative, the assigned number will get a regular SMS. In case of emergency session, only the doctor will get, the assigned doctor will get the SMS. This is the main part, and here is our prototype, and we can see we have used a variable to design our to connect all the equipments, and here our main part. We have used a IR sensor and photodioide sensor to detect our here the result. We have to test it with a dummy patient. One of our co-author have tested the result, and here are the results of 3 different persons. Here we are marked them as patient 1, patient 2, and patient 3. And here are the results, and here is the sample SMS we have get after the results, after the checking using the device. And that's it. It's a very summarized presentation. So most of the detailed content are available on our paper. I try to keep it short. At the end, we can see that this device is there are other options which are costly, but here we have used microcontroller to cut down the cost and use mostly cost-effective equipments to design these systems, and the overall cost of this device is 1,500 Bangladeshi taka, which is equivalent to $15 right now. And here are some scope of improvement. If we can connect this device with IoT server and monitor the patient's health data regularly and generate view graphical presentation, that will be helpful for doctor to keep record and to see the improvement of patients. Thank you. That's all from my presentations. If there is any questions, that will be appreciated. Thank you. And
thank you so much for such a nice presentation. My congratulations to you, and no specifications. Yeah, we can continue now.
Okay, sir. Thank you so much. Thank you, dear presenter, for the great presentation.
thank you.
Now, I would like to invite our next presenter.
Am I audible?
Yes, sir, you are audible.
Yeah, we can continue.
Yeah, okay, sir. I want to invite our next presenter, Polikwan Jadjit, and she is presenting the knowledgeable management model for spa business entrepreneurship in the upper northern Thailand. Sorry if I pronounce the name wrongly. Maybe she's not here. Okay, for moving to our next presenter. Just a second. Han Tong Tran, and she is presenting on medical record sharing system based on blockchain, a case study in Vietnam.
Okay, I'm here.
Dear presenter, you may please start your presentation.
Yeah, I will stay at the screen. Window. Do you see my slide?
Yes, sir, we can. And please make it full screen.
Okay. Good afternoon. I will resend
Yeah.
our yes, okay. I will resend our work related to the medical record sharing systems by on the blockchain. A case story in Vietnam. The outline of presentation today, I would like to talk the motivation at the first session. The next session, I will tell you the research objective, then the system architecture, then some designs on the blockchain for our robust method. And I will tell you the implementation and experiment in our research, and finally, this conclusion. The electronic medical record have to solve the problem of storing, retrieving, sharing, and searching the medical data easily. They also need to share the patient electronic medical records between the hospital when the patient is transferred from one hospital to another. However, a electronic medical record are the most important information. It needs to carefully protect it. For the motivation, you can see in the recent year, the blockchain technology and its application have readily emerged. The necessary decentralized database maintained by the collective and now value in the very field. The blockchain can solve the security problem of the electronic record, medical records due to its transparency and security robustness. We for the operation in this story, we report a distributed electronic medical records management system that allow the electronic medical record to be stored and shared between the hospital, particularly for the sky story in Vietnam. That can use the blockchain technology to store and share electronic medical records. And we also the asymmetric cryptography to rotate electronic medical record data from the unauthorized user. The general architecture of the robot system has three main components, including a Python web service manage basis objects of the system. For example, medicine, disease, user, medical examination information, lineage, the treatment department, the clinical services, rally, and the personal records. The second component is the another ZS service interaction with the blockchain network. And finally, the React Web Client provide interface for the user and interact with the two web service to assure the user requirement based on in the figure in this slide. This figure shows the main data structure design in our system. Due to limitation of space, we show only the name of the data structure. The full detail of this data structure, including their robustness and a description, can be found in our paper. Generally, there are totally 22 data structure. The highlighted data structure those are directly related to the medical records are stored in the blockchain network, while the remaining are stored in the relational database. We also developed some change code in the blockchain is shown in the upper table. The setup in an electronic medical record is illustrated in the figure. When creating a medical record for the patient John, the doctor Nguyễn Nhân A can enter a medical record, then a randomly generated symmetric keys based the AES 256 rectal system with a key plan of 266 bits can be generated in the two. The doctor Nguyễn Nhân A can use the symmetric key to encrypt the patient data and sell encrypted medical record information to the blockchain. The doctor Nguyễn Nhân A can use his own policy key Nguyễn Nhân A to encrypt the symmetric key and share it in the decentralized sharing of the medical record and the blockchain. At the same time, Dr. Minh Yang A can also use the balance key zone of a patient zone to encrypt the CMS key data and save it into the decentralized sharing of the medical record on the blockchain to send medical records later. The figure illustrates the process of sharing on electronic medical records. The doctor Minh Yang A needs to share the medical record when the patient wants to transfer hospital. Let us say Minh Yang A needs to share this medical record with the Dr. Alice. At one, Dr. Minh Yang A gets the authorization data information on the medical record from the blockchain. In two, blockchain return the enriched data containing the CMS key next entry. The Dr. Minh Yang A can use his own private key Minh Yang A to decrypt. The decryption process is successful. At first, Minh Yang A obtained the CMS key in part, and then in part, Dr. Minh Yang A can use Nguyễn Thị B, but the key Nguyễn Thị B to encrypt the CMS key data and save it to the decentralized share medical record table on the blockchain. On Nguyễn Thị B side, we can get the authorization table information on the medical record from the blockchain. The blockchain return enriched data containing the CMS key. Then we use on Rabbit key Nguyễn Thị B to decrypt in ACE. The decryption is successful. The Nguyễn Thị B obtained the CMS key in 9. Then Alice used the CMS key to decrypt the medical record information from the blockchain in 10. The decryption process is successful. Then Nguyễn Thị B read the medical record of John in 11. In this study, we use the Hyperledger fabric framework to build the blockchain network for the system. The figure in the slide describes the architecture of a blockchain network used in this system, which have two organizations running on the same channel. Each organization has two peers, so there are two peers in the network. Each peer have a copy of ledger and the smart contract. The network have an orderer and use the PPFT consensus algorithm. And this is some interface of our application. For the system evaluation, the system use the Hyperledger Caliper, a blockchain bandmask tool in the Hyperledger ecosystem to measure the blockchain performance. For the evaluation measures, we use the success rate, the transaction per second, the transaction latency, and the resource utilization. For the environments, we use a machine with a CPU core i5. For the software, we install the operation system with Ubuntu. The tables present the performance of a robot method, where the TPS is the number of transactions per second in the caliper chain frequency option. The success denotes the number of successful transactions, fail is the number of failed transactions, and change rate is the capital rate required to the transaction. The robot shows the average number of the transaction processed per second. As on the table, the number of transactions per second regularly in range from 15 to 35. The change rate in the robot regularly increase from 15.1 to 35.2. The minimum latency and average latency remain constant at 0.01 seconds and 0.02 seconds respectively. In addition, the maximum latency reached the maximum ratio of 0.13. 13 seconds. When the number of transactions per second is centrified, the maximum latency reaches the minimum threshold of 0.07 seconds, while the number of transactions per second is 15 to 20. Our study about the blockchains by electronic medical record sharing system. The system prototype provide the most basic functionality of the hypercore electronic medical record management system. The many test case have been developed to test the system functionality, especially with respect to the relevancy of the electronic medical records. The evaluation show promising result with a good, robust, and low average latencies. It indicates the blockchain potential technology for the building an electronic medical record sharing system. This is the end of my presentation. Thank you for your attention. Thank you.
Thank you for the presentation. Vijay sir, you have any question for the presenter?
It was a very nice presentation. Thank you so much. I have no specific questions. You can go ahead.
Okay. I think the sir doesn't have any question. Thank you, sir, for the presentation. Okay, now I would like to invite our next presenter. Preeti Mandal, and she's presenting on secure monitoring of unauthorized UAV by surveillance drone using NS.
Yes, sir.
The presenter, you may please start your presentation.
Is it visible, sir?
Yes, ma'am, it is visible.
Good afternoon to everyone. Today I am Preeti Mandal going to present my presentation on the topic of secure monitoring of unauthorized UAV by surveillance drone using NS2. So these are the contents: introduction, objectives, proposed system model, proposed methodology, simulated results, conclusion, and bibliography. So, as the enormous application of UAVs makes it suitable for both civil as well as non-civilian sector for any emerging technology, along with its advantages, disadvantages are also needed to be dealt with. Easy accessibility and low cost creates an alarming situation of using UAV inappropriately. So a proper monitoring system is required towards the unauthorized UAV. In order to do so, swarm of UAVs could be used to determine the presence of unauthorized UAV in a particular area. So the main objective of this work is taken upon continuous tracking of unauthorized or intruder UAV after detection and transmitting the information to the ground base station securely using NS2 platform. This is the proposed system model, which is depicted in figure 1. The proposed system model comprises of aerial UAV nodes deployment and ground base station. Proposed algorithm is used to track the unauthorized UAV, and proper routing protocol is used to transfer data among the swarm of UAVs and to the ground base station. After detection of unauthorized UAV, its location is continuously sent to the base station for further processing and action. The important advantages of the proposed systems are as follows. After detecting the unauthorized UAV, continuous location of it is tracked using proper routing protocol and sent to the ground base station for further processing. Data transmission includes the location of unauthorized drones. The packets are securely transferred with a newly proposed cryptographic techniques. So this proposed methodology consists of proposed tracking method along with the proper routing protocol and the proposed cryptographic algorithm. So starting with the proposed tracking method. For tracking or monitoring of UAV in general, several sensors could be used such as radar, lidar, as well as camera, etc. In this work, for monitoring, an algorithm is used by considering a continuous maneuvering and the movement of UAV. It is assumed in Kalman filter that the present state is evolved from the previous state. So the present state could be represented as shown in equation 1, where A is the state transition matrix and T is the current state and T minus 1 is the previous state. W of T is the system noise and the observation and coming to the observation state, which is measured from the sensor, is represented as in equation 2, where G is the measurement matrix and UT is the measurement noise. Coming to the estimation of prior state and covariance matrix, which can be represented by equation 3 and 4, where M is the total number of predictor value and Q is the noise covariance. Coming to computing the gain of the filter, which is represented by equation 5, and finally updating the state, which is one of the important or the crucial step in this algorithm, is equation 6 and 7. In equation 7, the second part determines the second term determines the direction of the UAV movement, which follows the principle of dragonfly, which is depicted in equation 8, where S represents the separation between the drones while monitoring the unauthorized UAV to avoid collision among themselves. V represents the tuned velocity of the swarm of UAVs to work in alignment towards the task. E and F represents the distance which is to be maintained by the UAV to find the unauthorized or the intruder UAV. Then finally updating the covariance with the equation 9. Algorithm 1 depicts all the steps which are followed by while simulation, starting with the step 1 by initializing all the parameters shown in step 1, and then by repeating from step 3 to 10 for each cycle of from time t and up to time out, which will be varying according to the practical situation. And then finally secondly coming to the routing protocol. So based on the system model, it could be observed that different kind of interaction between the nodes are to be maintained. One among the UAV nodes in the sky and other UAV nodes to the ground base station. Ground base station is fixed in scenario, which works as a reliable backbone of the entire system. It indicates heterogeneous routing, which needs to be adapted. So already existing proposed technique by Lee et al., a technique load, carry, and deliver routing, which is used to enhance the connectivity between the UAV and ground base station, could be used. It uses disruption tolerant network in the sky, while for ground base station, ad hoc on-demand distant vector could be used. Coming to the proposed encryption and decryption algorithm, which is represented in figure 2 and figure 3. Coming to proposed encryption algorithm, which is an improved and the most secured version of traditional AES algorithm. In the proposed algorithm, initially the data to be encrypted is considered as the plain text of 16 byte or say 128 bits. Then the plain text is divided into 4 blocks and 4 cross 4 state matrix. The add round key is obtained by 128 bits of state XOR with the round key, which is a transformation of ciphertext followed by the substitution of the bits which are arranged randomly, and the order is stored in the lookup table, that is S box. The next step is to shift row, as 128 bits of plain text is placed in 4 cross 4 matrix. Then the shift operation is performed for the 4 rows. First 4 rows remains intact, while second row of the matrix moved circularly towards left. Third row is circularly shifted towards left twice, and fourth is circularly relocated towards left 3 times. In the mixed column state, the 4 columns are combined in the reversible way, which could be accessed back. This could consider as a matrix multiplication. The steps are repeated for n minus 1 time. Here, n is equal to 10 is considered as the plain text is considered to be 128 bits. This may vary according to the number of bits. In the last round, nth round, mixed column step is not considered. Only 3 steps are there. After add round key, in the last step, the bits are crossover with the random crossover key, which is to be noted as the secret key, and the output is further muted and after a constant number of bits. The remaining bits after the crossover of the add round key, that is and the secret key. This secret key makes it more secure and robust. This proposed encryption technique makes it secure and symmetric encryption method and faster than the asymmetric method. The decryption method, which is depicted in figure 3, is first demuted from the particular bits. Then using the secret key, crossover is performed. Similar to the encryption technique, 4 stages, inverse shift rows, inverse sub-byte, inverse mixed column, and add round key are performed for n-1 times using round key. In the last round, inverse mixed column stage is considered. Finally, the plain text is obtained. Then coming to the simulation results, here the proposed algorithm is analyzed in the NS2 environment, that is Network Simulator version 2, for continuous updating the location of drones in the base station. Information is sent in the packet securely. The parameters for the simulation are considered in table 1, which are as follows: number of nodes, that is 4, 3 surveillance UAV, and 1 is considered as the intruder UAV. Channel is considered as the wireless channel. Protocol is LCAD protocol. Antenna is considered to be directional antenna. Energy consumed by each node is 3 joules. Transmission and the reception power is 0.175 watts. And movement model is considered to be as random waypoint model. So the monitoring of nodes and data transfer in the NS2 platform can be observed in NAM file, which is depicted in figure 4. Here we can see that the surveillance nodes are represented in green color, and unauthorized intruder UAV is represented in red color, and the ground base station is represented in blue color. These are the position of the intruder UAV and the position and the speed of the proposed tracking algorithm by using, and then finally the output of the proposed encryption and decryption algorithm. And then coming to the figure 7, it depicts the distance error computation while tracking unauthorized UAV. Proposed hybrid method performs with much more accuracy as compared to the existing algorithm. The packets are transferred by encrypting it using proposed algorithm. The performance of the proposed algorithm analyzes using the throughput depicted in figure 8. From which we can see like greater throughput of the proposed algorithm represents its higher performance. Figure 9 and 10 depicts the encryption and the decryption time for various packet size, as the proposed algorithm takes lesser time for encryption and decryption. It is more efficient than the other algorithm. Proposed cryptographic algorithm outperforms as compared to the conventional method. So coming to the conclusion, in this work, continuous monitoring of UAVs, unauthorized UAVs using surveillance drone or UAV is simulated using NS2 platform. The proposed monitoring algorithm performs better as compared to the existing algorithm, which is analyzed in terms of distance error. The information about the unauthorized intruder drone is securely transmitted using newly proposed cryptographic algorithm, which performs better in terms of throughput, which makes it more efficient, secure, and faster. These are the bibliography which I've used. Thank you.
Yeah, thanks for the presentation. Very nice idea and very nice presentation.
Thank you, sir.
So now we can proceed ahead.
Okay.
Harsh,
Thank you for the great presentation. Okay. So moving for our next presenter, Loikwan Jadis,
yes.
and she's presenting on the knowledge management model for spa business entrepreneurship in the Upper Northern Thailand. Dear presenter, you may please
Yes.
start your presentation.
Yes. Okay, I will share my slide.
Yes, please.
And some problem of the internet moment, please.
So you are able to present right now or not?
Yes.
If you
Oh,
have
the
any
internet.
technical issue, You can solve it. Till then, we can consider next presenter. After that, you can present your paper.
Okay.
Okay?
Okay.
Okay then. Okay, so our next presenter is, just a second, Jefferson Bongwasi, and he is presenting on risk reduction and emergency response utilizing beacon and mobile technology. Dear presenter, you may please start your presentation.
Okay. Good afternoon, everyone. I am Dr. Jefferson Bombasi from the Philippines. On behalf of my co-author, Dr. Ronaldo Wanatas and Dr. Jasmine Nigidilla, I will now be presenting our research entitled Risk Reduction and Emergency Response Utilizing Beacon and Mobile Technology. May 14, 2015, in an article published.
Sir, we cannot see your full slide actually. It's cutting window.
Hello?
Yes, sir. You can now you can reshare the screen and make it full screen so we can see it full.
Okay.
Yes.
Okay.
Now it's good. Now it's good. Thank you.
Yes, so to continue, so May 14, 2015, in an article published by CNN Philippines, 72 people were killed by fire in a footwear company. December 23, 2017, in an article published by Rappler, 37 were killed by fire in a shopping mall. And April 22, 2019, in an article published by CBS News, people were trapped inside the collapsed building amidst power interruption brought by a strong earthquake. These were unfortunate events that happened despite in-place emergency plan, and the buildings involved were compliant to the Building and Fire Code of the Philippines. So clearly there are gaps in the current building emergency plans and programs, the reason why these events happened. The gaps are: number one, emergency plan is focused on visuals. Yes, there may be emergency signs and maps on the wall, but if the power in the building goes out, people can hardly move when the area is dark. There are emergency lights that could at least guide people inside the building, but most of the time, due to irregular maintenance, emergency lights most often do not work or too dim to shed light. This could have caused people to get trapped inside the building because it is difficult to locate the emergency exits. In case of fire, we are almost like blind due to heavy smoke. It is difficult to find the nearest fire or emergency exit amidst the clouds of smoke. The smoke coming from the fire affects the visibility of emergency lights, signs, and maps in the wall, hence preventing people to find the nearest fire exit and make them trapped inside the building. Second gap is the efficacy of emergency response affected by the external factors and respondents. In the Philippines, we have emergency response, and each local government unit has emergency response team. The goal of the team is to rescue the people, but in most cases, emergency response usually came late during the post-impact phase, while we can save more lives during the pre-impact and the impact phase. This can be due to external factors like traffic, damaged vehicle, not to mention that for the safety of the rescuers, rescue will be given when the safety of the rescuer is secured, most of the time during the post-impact phase. In fact, literature also reveals that only few research papers are focused on the person who experiences emergency. Most researches under risk reduction and emergency response are intended for external responders or rescuers. This is, I believe, another gap because it is also important to cover the systematic response of the people inside the building during emergencies, as this can save more lives and not to wait for the rescuers. No one can help people in real time other than themselves. With the research gaps I mentioned, we came up with this research entitled Risk Reduction and Emergency Response Utilizing Beacon and Mobile Technology. This study utilizes mobile and beacon technology to help in risk reduction and emergency response of building occupants during a disaster. This will provide assistive response to people to escape from a building in case of earthquake or fire. This will make use of sound or voice as guide in addition to visuals as part of emergency plan that is to address gap 1. This will also utilize beacon sensors and mobile application as part of emergency response, which will make the people themselves the first line of response to save their lives and not to wait for external responders during emergency, thus addressing gap number 2. The research design has 6 components. The research diagram has 6 components. First is the beacon sensor, which is a wireless technology that can send signal to smartphones. Beacons will be installed to create a path that will locate the nearest emergency exit inside the building. Second is the Bluetooth technology. Beacon will rely on Bluetooth low energy or BLE to send distance or proximity. So third is, so once the beacon is installed, it will constantly transmit BLE signals that can be scanned by smartphones. Third is the smartphone. It is the mobile phone that can run third-party application, but nowadays almost all smartphones are Bluetooth enabled, making it ready to communicate with any beacon available. Fourth is the algorithm that will scan, detect, and select the closest beacon. Fifth is the voice technology or the text-to-speech API, which will convert distance data into natural sounding voice, which can be heard by the user. The 6th component is the mobile app itself. The mobile application is based on the algorithm and will be programmed using text-to-speech API. The app will communicate and manage all the components. The mobile app must be programmed to continuously scan and detect beacons, select the closest beacon, reads distance information, and convert it to voice data. Beacons will create path to the nearest emergency exit from any point in the building. First, the number of beacons needed to install must be computed. If a building or a structure follows the Building and Fire Code of the Philippines that no point in a building shall be more than 61 meters from the exit, then the number of exits per floor in the entire building is equal to the number of beacons needed to install. However, in some cases, where passageway or a balcony can serve as an exit or as an exit, like in hotels and big malls, additional beacon is required. The range of beacon is 70 meters. So if the length of the line, or line of travel in a certain area or floor going to exceed 70 meters, additional beacon is required. Second is the localization of beacon. One beacon must be placed on each exit or passageway. If the line of travel again going to exit is more than 70, then additional beacon must be placed for every 70-meter point. Third, the beacon must be installed at a certain height, ideally 3 to 4 meters from the ground or in the ceiling, establishing line of sight to any person at any point in the area. For the emergency response, the mobile application will be utilized to respond to building evacuation during emergencies. The mobile app will provide voice assistance in terms of distance or proximity based on path created by the beacon localization and installation until the user reaches the emergency exit of the building. The technology works this way. If the closest beacon is detected, it will give you the distance in meter. The nearest exit is 50 meters away, and so on and so forth. As you get closer to the exit, the distance is diminishing, so you know that you are getting near the exit or in the correct direction. If you move to opposite direction, then the distance increases. So the study is significant to all building owners and managers who prepare and implement building emergency plan, as well as all people who occupy and use building, especially if you are new and not familiar in the building or any establishment. This will ensure the safety and security of building occupant while inside the building. For the research design, we use quantitative method. A survey was conducted using an instrument to determine the acceptability of the research. The questions were based from the criteria of TAM model or technology acceptance model, particularly the 3 criteria: perceived usefulness, perceived ease of use, and the system complexity. The respondents who participated in the survey are 2 mall managers, 2 hotel managers, 6 facility officers, 3 civil engineers, 8 officers of the National Disaster Risk Reduction Management Council and the Bureau of Fire Protection, 3 from the local government unit, 2 building occupants, 2 persons with disability, and 2 senior citizens. So for the perceived usefulness, the first criteria, which is composed of 6 questions, these are the means that we got, and the interpretations are all strongly agree. With a rate of 4.88, the respondents strongly agree that the technology would improve the emergency response inside the building, and the framework can reduce or eliminate disaster risks. For the perceived ease of use, which is the second criteria, there are 4 questions. The mean, we got these 4 means, and the interpretations are all strongly agree. With the rate of the average mean, which is 4.967, the respondents strongly agree that the technology is easy to implement and use. And for the third criteria, system complexity, composed of 4 questions, interpretations are all strongly agree. The average is 4.965. The respondents strongly agree that the technology is clear and convenient to use. So in total, getting all the average with a rate of 4.93, the experts and respondents strongly agree that the risk reduction in emergency response utilizing beacon and mobile technology could improve the emergency response and reduce or eliminate disaster risk in built environment. So to determine the level of reliability of the instrument we used in the survey, we also get the Cronbach's Alpha, which is a tool for assessing the respondents' responses. So the value that we get is 0.898, which is commensurate to good in terms of high level of internal consistency and reliability of responses. In conclusion, risk reduction and emergency response utilizing beacon and mobile technology can improve the emergency response inside the building and can reduce or eliminate disaster risk. The technology is feasible, easy to implement and use, clear, convenient to use, can serve as basis to every building emergency plan, and is well suited to all emergency response program. So the technology also offers cheaper implementation cost because of the cost is just beacon. The technology was strongly accepted by the experts and the respondents. So risk reduction and emergency response utilizing beacon and mobile technology also supports the Sendai framework for disaster risk reduction 2015-2030. And lastly, the Philippines also embraces smart technologies in buildings. So we have air conditioning, lighting, and security, which are the 3 primary considerations when establishing smart buildings. So the 4th primary consideration could be disaster management. Upon implementation of this research, disaster preparedness, response, and recovery could be achieved. Thank you.
A very nice presentation. Thank you so much. It's indeed a good work. Congratulations.
Thank you, sir. So is there any question for the presenter?
No specific questions. It was a nice presentation.
Okay, thank you so much. Okay, so moving for our next presenter, Lukwan Jadjit, please present your paper.
Yes. I already shared my slide, but it did not work. Moment, please. Sorry. I have some problem about the training.
Sorry, I didn't get you.
You hear me?
Yes, I can hear you.
Okay.
So you are able to present your paper right now or not, ma'am?
Yes, I will share my slide now.
Okay.
You see my slide?
No, ma'am, we cannot see it.
Oh, okay, I will try again. My slide. I have some problem about technique for share a slide.
So, is it working or not, ma'am? Actually, I don't get you what the problem you are facing right now.
Okay.
I think you can re-log in. You can log out and then re-log in. Then you can share your slide. You can log out and then re-log in.
Share. Okay.
Yes, now it is visible. Make it full screen and start your presentation.
Now it is visible.
I already share.
Yes, please make it full screen.
Yes. I already share my slides.
Yes, yes.
Okay.
We can
It will be
say.
like this one.
Moment,
You can
please.
continue.
I will go to slide share. Okay. Okay. Okay, today, good afternoon, everybody. Today, I will present one part of my research about knowledge management model for spa business in Upper Northern Thailand. I am Dr. Hoi Kwan from Thailand. Today, I start at the background and introduction of my research. The Thai spa is very famous worldwide, a promising business that generates a lot of income for Thailand. Thai spa in each region are different, especially the spa in the upper northern Thailand is top rated among the tourists because of its unique identity of charm, incorporating the local culture into the main service. According to Thai strategic plan, there is a plan to push Thailand into a medical and wellness center. As a result, there is very strong competition in the spa business. However, very few spa entrepreneurs are certified there by the Ministry of Health because most of entrepreneurs still have improved many skills to bring their spa to meet international standards that help create market value. Therefore, it should provide the entrepreneur with more skill or knowledge for raising their performance by using a concept of knowledge management that lead to the objective of this study. For the one of the objective of this study is the research aim to develop a knowledge management model for wellness spa operator in upper northern Thailand. So this one is the scope of my study. The first one is the area of the study. I studied in the up northern Thailand region. They compounded Chiang Mai, Nan, and Lampa is the sample of my research. And next one is the population and key profile. The first one is the entrepreneurship, the manager, the director of spa in Chiang Mai, Nan, and Lampang. And the second one is the customer. So, and the last one is the expert in spa, or the owner, the manager, and the academic expert in spa also. The content of the study is study the existing knowledge of the entrepreneurship in the upper northern Thailand and the customer expectation who was in upper northern Thailand, and for we have information, we use information to develop the knowledge management model for the spa entrepreneurship in the upper northern Thailand. Next slide is the research methodology. For this objective, we study by use the concept of six model. They compound with context, input, process, and output. In the two, or the theory is the spa entrepreneur knowledge model and the adult learning and pedagogy. And the next one, the result or the expected outcome, we expect the knowledge management model of the spa entrepreneurship in the upper northern Thailand. They can use the model for develop their business or develop their employee skill for improve their business to bring a lot of income. And next one, I will show you the research result by the objective. So this is my research result. Yes, the first one is the context by the framework of this model. The context is spa. The context is the spa in upper northern Thailand. I study about the knowledge in the entrepreneur, the customer satisfaction, and the quality satisfaction by 5A in tourism. And the second one is input. Input for this study, we found that they compound with human resource management, product and service, physical environment, standards, service standard, and foreigner skill. And the second one is product. It's process. We driving the process by use knowledge management that consists of the that capture the information from the expert and use the adult learning inequality by improve or share the knowledge for reskill or up skill for the entrepreneur or the director, such as seminar, training, or workshop. And the second one is the product output. The next one is product output. We found that the model, we developed the model for the entrepreneurship by use the theme of knowledge management, and for the driving mechanism for driving or improve that skill, we use adult learning experience and readiness to learn, because most of the entrepreneurs, they are adult and have many experience. So I think we use adult learning is good for them. Okay, and this one I will show you the context of spa in upper northern Thailand. There are comprised with 5 sense of sight. The first one is the sense 5 senses. The first one is sense of sight. The second one is the sense of touch. The next one is sense of taste, sense of smell, and sense of sound. The most all of sense is present upper northern Thailand identity. For example, this sense of sight, they present the decoration that use Thai Lana or upper northern Thailand, culture of Thailand art. And for the sense of touch, we have some unique massage that adapt by Thai upper northern Thai dancing. We call fawn lip, and for the taste we use Thai herb, and for the smell we use Thai herb, Thai flower, Thai aroma. Yes, and instead of sound we use Thai upper northern Thai music. And the 5A in tourism, there are attraction, accessibility, and amity, accommodation, and activity. We use 5A for a framework that by the customer or tourist satisfaction, and the input by a SIP model framework. They comprise with human resource management, product and service physical environment, service standard, and foreign language, and knowledge management process. We compile that seminar, training, and workshop. And the driving mechanism is adult learner and readiness to learn. And product output is the model for develop the upper northern Thailand spa entrepreneurship. And for the certification from this research, I found that Thai spa in upper northern Thailand would attend more training program and seminar update their knowledge usually, because some of spa their knowledge is out of time. They should develop their skill many times for many or more competitive advantage for their business. And finally, I will show you a conclusion or the research novelty. For my research find that a service in spa in Upper Northern Thailand is attract tourists or customer by their five senses identity, and they should apply or improve their local cultural local identity for present their business also. Thank you.
Yeah. Can you hear me?
Yes, sir, we can hear you.
Yeah, it was very nice presentation. So, can you tell me like why you have taken only this Upper Northern Thailand as a study?
Yes.
Why only Upper Northern Thailand?
Yes, Upper Northern Thailand.
So why have you taken this Upper Northern Thailand only? You could have taken this Southern Thailand also and the down Thailand also. So why only Upper Northern Thailand?
Only about not Upper Northern Thailand.
Yeah. Why
Yeah.
why you have opted this?
Yes.
You are doing your study. Yeah, you are
Yes.
doing your study for Upper
I am
Northern
not
Thailand.
here. I am not hear you.
You don't hear me?
Yeah.
Okay. So, like in your study, in your knowledge
Yes.
management system, in your knowledge
Yes,
management
knowledge
system,
management.
yeah, you have taken Upper Northern Thailand.
Yes.
So why you have taken this?
Oh, I choose Upper Northern Thailand is because there are a lot of spa in Thailand. Most of spa in Thailand, they stay in Upper Northern Thailand, and Upper Northern Thailand will become World Heritage.
Okay, okay. And what is the use of information and communication technologies in this knowledge management
Yes.
system?
Yes, knowledge management.
What is the use of ICT in this?
ICT. Sorry.
How can this ICT be used?
Oh, ICT use SIP model. Yes, the SIP model I use for develop my conceptual framework, because the SIP model is the model for evaluate the project or the evaluate the model, the evaluate the knowledge management model.
Okay, fine. Thank you so much.
Thank you.
Congratulations.
Thank you.
Thank you, Professor.
Okay. Thank you, dear author, for the presentation. Okay, now we are moving for our closing remarks. I sincerely thank our authors for their excellent presentation and great contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. And we, on behalf of whole team, thank you for your support during this version. And we will be happy to have you all in the next version of this conference in 2023. Now all the participants will be getting the digital certificate through email within 2 working days. And further, all the papers have been already forwarded to the sender. And the publication will be live within 6 months, hopefully forwarded with the team ISBM 2022. Now, I also thank our session chair for chairing the session, Professor Vijay Singh Rathore. There is a token of appreciation on behalf of Global Knowledge Research Foundation and the team ISBM 2022.
Thank you so much.
Thank you, sir, for your valuable presence. And now, in the end, I like to request you all to turn on your camera to take some quick snapshot and make this conference more memorable. Maybe I am facing some issue with camera. Wait. Just a second. Thank you. Thank you all.
Thank you.
Thank you, sir.
Thank you. Thank you so much. Thanks to all for the nice presentations. My best wishes to you all.
Okay. Stay safe. Take care.
Take care. Bye bye.